The objective of this video is to learn how to conduct a hypothesis test about the significance of the linear relationship between two variables. The table shows the relationship for 17 randomly selected students between the number of hours spent studying per week and the student's GPA. The graph shows the scatter plot for this correlated data. This graph shows a positive linear relationship. It is a positive relationship because as the values of the independent variable increase, the values of the dependent variable also increase. For this relationship, the sample correlation coefficient is R equal to 0.864. Recall that the closer the value of R is to positive 1, the stronger the positive relationship between the variables. The closer the value of R is to negative 1, the stronger the negative linear relationship between the variables. The closer the value of R is to 0, the weaker the linear relationship between the variables. The Greek symbol rho is used to represent the population correlation coefficient. The lowercase letter r is used to represent the sample correlation coefficient that is used to estimate rho. If rho is equal to 0, then there is no linear relationship between the variables. We must use a hypothesis test about whether the value of r is high enough if we are to conclude that there is a significant linear relationship between the variables. There are 4 assumptions for testing the significance of the linear correlation coefficient. 1. The data are quantitative and are obtained from a simple random sample. 2. The scatter plot shows that the data are approximately linearly related. 3. There are no outliers in the data. 4. The variables x and y must come from normally distributed populations. Step 1 in the hypothesis test is to state the hypotheses. The null hypothesis will be that rho is equal to 0. The alternative hypothesis will be that rho is not equal to 0. There is no need to place the claim in this type of hypothesis test, as this test is always about whether or not there is a linear relationship between the variables. If we reject the null hypothesis, then we will conclude that a significant linear relationship exists between the variables. Step 2 is to find the critical values. We can use a t-distribution table or technology such as the TI graphing calculator to find the critical values. The number of degrees of freedom for this hypothesis test will be the number of pairs of correlated data minus 2. In order to find the critical value, we will also need to know the level of significance. Alpha equal to 0.05 is very commonly used as a level of significance in this type of test and is what we will use for this example. The critical values are plus or minus 2.131. You can review the process for using the t-distribution for finding critical values in the videos for Chapter 8. Step 3 is to compute the test value. The formula for the test value requires that we know the sample correlation coefficient and the number of correlations in the sample. The correlation coefficient is 0.864 and the sample size is 17. The result is a test value of 6.646. Looking at a distribution, we see that the rejection area lies to the left of negative 2.131 or to the right of positive 2.131. Our test value is so extreme that it doesn't even appear on this graph. Step 4 is to make the decision. Since the test statistic landed in the rejection region, our decision will be to reject the null hypothesis. Step 5 is to summarize the results. Since we have rejected the null hypothesis that the population correlation coefficient is equal to 0, we conclude that it is not 0. Therefore, we conclude that there is a significant linear relationship between hours spent studying and GPA. In this video, we learned how to conduct a hypothesis test about the significance of the linear relationship between two variables.